Today we're going to be going through the basics of wiring a socket circuit. For this demonstration, I've created an example of a wall. What we have here is a couple of studs with a dwang running between. Through the dwang is a drilled hole that the cable runs through. And down here is a piece of jib that represents the outside of the wall that you can see visually. And behind that is a flush box. And the flush box is generally what sockets screw back to. You can have things called C-clips, which clip in the middle of the wall. They don't need to be screwed into a stud, and they fix the fitting straight back onto the jib. The cable I use here is a 2.5mm TPS. It's generally what we run these days for socket circuits in residential properties. On the left hand side here, this circuit breaker and these two cable cores represent a switchboard setup. So the cable's going to run directly from the switchboard out to the first power point on a circuit. For this video, we're just doing one power point for the circuit. In the switchboard on this end of the circuit is a circuit breaker. These days when we install new cables, they must be run off an RCD. So upstream of that circuit breaker will be an RCD. Depending on the age of the house, if it's an older property with older cables, it may or may not have an RCD existing on the circuit. This black cable here will go back to the RCD neutral or neutral bar, depending on the age of the house. And then the earth cable here goes back to the earth bar in the switchboard. If you want to learn more about the switchboard side of things, check out my videos on how to wire a switchboard. That will explain this side of things much more in depth. I will leave the link for that in the description here, so go check it out. When you're wiring a socket circuit, the cable length hanging out of the flush box that you want to be able to work with should be the distance from the knife edge of your hand to the end of your thumb. So if we look at this one sticking out of the flush box, it's a good enough length to work with. From this flush box here, I'm going to demonstrate wiring a socket onto the cable. If you want a more in-depth guide, check out my video called How to Replace a Socket Outlet. I'll leave the link for that in the description as well. First thing I'll do, grab my side cutters out, cut a slit in the end of the cable between the cores, grab onto one of the cores and peel them back. And then I'll cut off the excess insulation. Next part, I trim the ends off about 1 centimetre, and then from these cores here, make a wee nick about 1.5 centimetres in. Just in the insulation, I don't grab into the copper. Do the same on a 90-degree angle, so there's a wee groove going all the way around the insulation, and then I hold it without putting pressure on the copper. Use my left hand holding the cable and press with my thumb on the back of the side cutters, and it strips the insulation off. I'll go ahead and do the same with the other two. Now with these bare copper ends, we twist them up. Trim the end back slightly. And then fold them over. When the copper cores are folded over, you want them to be roughly 1 centimetre in length. Next part we'll do is throw the socket on the wall. So you'll see A, E and N. A is active, which is your red live cable. E is for earth, which is your green cable. and N is neutral, which is your black cable. When you slide the copper cores in, make sure that when you screw the screw up, it's grabbing only onto the copper and not onto the insulation. And then tighten it up and do a pull test to make sure that that cable's not coming out. Now when you look on an angle, you should only see insulation and not copper. So looking at it from this view, we can't see any copper sticking out there, but when we look into it, we can see that the screw is only making contact with the copper. Chuck the earth and the neutral in. Do our pull tests, and then we fix the socket into the flush box using these flush box screws. Through the center hole, screw it in. When you screw them up, use a small level on it to make sure it's level on the wall, and then tighten the wee screws so you can't move it. Stay tuned for the next one, where I'm going to be adding a socket onto an existing circuit. Cheers for watching.